stuff we have mentioned before, so it's not all new, but we're just really taking a bunch of pieces and connecting all the dots between them now. So bringing everything together. So first thing, if we're talking about a derivative, what is it telling us about a graph? How are they related? What are some things that you know? For instance, we've just got done on our quiz finding like when a derivative was 0. If a derivative was 0, what did that tell us? The slope of the tangent line was 0, which meant we had a maximum or a minimum, right? What if the derivative is positive? These pink lines here represent the slope of a tangent line. All of those right here would have a positive slope. What's the graph doing right there? It's increasing. These lines would have a negative slope, and our graph is decreasing. Here, these positive slope and the graph is increasing. So we've talked about the maximum and minimum piece before, but what we haven't necessarily touched on is the increasing, decreasing. So, if the f prime of x is greater than 0, what you want to fill in on your notes, f is increasing. If the derivative is less than 0, then f is decreasing. Okay. Let's look at an example. I want to know when this function is increasing or decreasing. So based off the last piece, we know that has to do with the derivative, if the derivative is positive or negative. So the first thing I need to do is find the derivative. So derivative of x squared minus 4x plus 5 would be? Okay. If I want to figure out where this is positive or negative, what I first need to do is find out where it is 0. So we're going to find our critical point first. It means 2x equals 4, so x is 2. So if we think about this, when x is 2, that's when this thing is the derivative is 0. So that's either like a maximum or a minimum point. I need to figure out if it's positive or negative on each side of that. What I'm going to do is a sign line. We haven't done these in a while. Remember we picked test points on either side of 2? So something smaller than 2, maybe a 0, something bigger than 2, maybe a 3. And we're going to plug those into the derivative, because I want to know if the derivative is positive or negative. So if I put a 0 in here, I get 0 minus 4, which is a negative. If I put a 3 in, 6 minus 4 is positive. So that means this graph is decreasing until I get to 2. So from negative infinity to 2, my graph was decreasing. After 2, my graph started going up, so it's increasing from 2 to infinity. What's a quick way I could verify that? Graph it. Let's look at a graph real quick and just make sure that makes sense. Okay, so I'm just going to graph that original one to illustrate it for you. So we have x squared minus 4x plus 5. So if I'm looking at this parabola, it starts out decreasing. You can see right there at 2, it switched and started going up. So is 2 a maximum or a minimum on this graph? Minimum, good. Alright, let's try another one. So let's find the increasing or decreasing for this graph. So the derivative would be what? So there's my derivative. I need my critical points, which is when this thing equals 0. How will I find that? What could I do? We take out 12x. I'll use this with x squared minus x minus 2. And we could do box method. So x squared breaks into x. Multiply to negative 2 and add to negative 1. Okay, how many critical points do we end up with? 3. What are they? Let's plot these things on our sign line. You have to go in order, increasing order, so negative 1 goes first, then the 0, and then the 2. Okay, then we do test points is the easiest option. So smaller than negative 1, okay, negative 2, in between negative 1 and 0, in between 0 and 2, and bigger than 2. Okay. I need to plug these into the derivative. So you can certainly plug them in. Here, I prefer to plug them in once it's factored because it's a little easier for me to tell. If I plug a negative 2 in, negative 2 times 12 is negative. Negative 2 minus 2 is negative. Negative 2 plus 1 is negative. If you multiply 3 negatives, you get a negative. If you put in negative 1/2, 12 times negative 1/2 is negative. Negative 1/2 minus 2 is negative. Negative 1/2 plus 1 is positive, so this section is positive. Put in a 1. 12 times 1 is positive. 1 minus 2, negative. 1 plus 1, positive, so this section is. And 3, 12 times 3 is positive. 3 minus 2 is positive. 3 plus 1 is positive, so this section is positive. Do you guys all understand where I'm getting my positive or negative piece? So now we just have to answer the question. I want to know increasing and decreasing. So the positives are where we are increasing. So that would be from negative 1 to 0, union 2 to infinity. Then it would be decreasing from where? Any questions so far? Again, if I wanted to kind of confirm this, what would I do? Draw a graph and just confirm that. So let me ask you a question. Negative 1, 0, and 2. Can you tell me which ones would be maximums and which ones would be minimums? At negative 1, your graph was decreasing, and after 1 it's increasing. So negative 1 is a minimum. At 0, before 0 is increasing, after 0 it's decreasing, so 0 is a maximum. 2. was decreasing and then increasing, so it is a minimum. Now these are not the absolute maximums and minimums. To do that, we have to be like on the quiz, where you have to test the y values, but these give us our local maximums and minimums. So that is the first derivative test. So if f prime changes from positive to negative, that means it was increasing and then it was decreasing, you have a local maximum at C. So you're just filling in the blank, local maximum. If it goes from negative to positive, so decreasing to increasing, that's a local minimum. If it doesn't change sign, then there's no local maximum in there. So let's use this to find the maximums and minimums. So what's my first step? Derivative. So that gives me, was this the last example we did? Yeah, so I don't need to rework all that, do I? So we know from example 2, we had, okay, I'm just going to do this. So my local max is where? At 0. How would I get the y value if I wanted it? Plug it into the original. So if I put 0 into the original, I get 0 minus 0 minus 0 plus 5. Local minimum, we will have 2 of them, at negative 1 and positive 2. So we have to plug those into the original. So if I put in negative 1, I get 3 plus 4 is 7, 12, negative 5 plus 0. Is that what you guys got? Somebody's checking me, right? Is that right?
Part of the next one.
Okay. You put in a 2. What'd you get? So you do your derivative, you can find your increasing and decreasing, which helps us then identify the maximums and minimums. To get the y value for those, we plug them into the original. Any questions there? Let's do one more like that. So example 4 here. So find and classify all the critical points. So our derivative would be 6x squared minus 6x minus 36. What could you do to that? Take out a 6, that leaves you with x squared minus x minus 6. And you know when that equals 0, so then we could do box method. Multiply negative 6 and add to negative 1. Okay. So set that equals 0. The 6 doesn't give us anything. X minus 3 would give you a positive 3, and x plus 2 is a negative 2. So if we look at our sign line, we have to plug test points into the derivative. So smaller than -2 is -3. In between them maybe a 0, bigger, maybe a 4. I like putting them in right here. I know the 6 is positive no matter what. -3 minus 3 is negative. -3 plus 2 is negative, so that part's positive. 0 minus 3 is negative. 0 plus 2 is positive, so that's a negative. 4 minus 3 is positive. 4 plus 2 is positive, so that part's positive. I didn't ask for it, but if I did, where is this function increasing? -infinity to -2, union 3 to infinity, decreasing from -2 to 3. I asked for the local max and mins. Okay, so -2. You went from increasing to decreasing, so that one is a max. If you plug -2 into the original, -3, is that right? Maybe not, hold on. -51. Yeah, I think I dropped a negative there. At 3, it went from decreasing to increasing, so that one is a minimum. So plug a 3 in. -74. Are there any questions about that? That is our stopping point for today. I did post something on Classroom today, but you can just ignore it. That's just going to be what I start class with tomorrow, I think. I'm going to save it for then. So your homework is that handout I gave you with your notes. So the first 5 questions, I'm asking for local maxes and mins, so just like this one. Then the next 5 questions, I want the critical points and where it's increasing or decreasing. Okay? And you've got some time right now to work on that.